In this lecture, we talk about certain important constructions. So we start with something called CW pair. Now CW pair would be written as x comma a. X is your cell complex and a is a subcomplex of x. So a is also a cell complex, but all its cells and all its attachment maps etc. lie within a. So a is a closed subspace or a subcomplex of x. The standard example we will give is this: Rpn contains Rpi, that is real projective space n contains real projective space I. So x is Rpn and we are saying A is Rpi. So this Rpi is naturally contained within Rpn. So first we write the cell structure for Rpn. So n is greater or equal to I. So this is how our Rpn looks like: E0 union E1 union E2, and then you have somewhere EI, and then you go all the way to En. So this is your Rpn, and then you take these cells right here along with all their attachment maps etc. You get Rpi. So this Rpi is a subcomplex of Rpn, and that is how you get a CW pair. Now once you have a CW pair, you can form a quotient like x over a, from this pair x comma a. So what is this quotient? You just get rid of all this a, x minus a, and instead of a you put a 0 cell corresponding to this subcomplex a. So the way to see this is via an example. So dn, and the boundary of dn is Sn minus 1. So this is nothing but boundary of dn. So this will be Sn. So to see this, you first have a disk. So this disk is D2. The boundary of the disk is S1. So this boundary is S1. And we are trying to find D2 by S1. So you take this S1 out and collapse it to a point. So you're taking x minus a, so that will be D2 minus S1 and 0 cell which corresponds to S1. So you have to collapse this S1 to a point. So once you collapse this S1 to a point, what you get is a sphere, and this entire boundary is collapsed to this point. So we have a sphere here S2. So that is our standard example. So D2 by S1 is equal to S2. So dn by boundary of dn Sn minus 1 is Sn. You collapse the boundary to a single point. Now we talk about cone and suspension. So cone of x is x times this unit interval I. So I is nothing but this unit interval going from 0 to 1, and then you identify all the top points of this interval. And suspension is you take the unit interval and identify the top point 0 and the bottom point 1. So this is more clear in a diagram. So let us see this. So say you have the space x. To start with, first you attach the unit interval to it. So you have to attach unit interval like this at all the points of x. So after you attach this x times I to it, then this is say the 0 part, and this is the 1 part of the interval. So this entire thing is interval I. Then you collapse this 0 part to a point, and what you get is a cone. And anyway, the part which is coming under the x, this you retract back. So you do a homotopic retraction back to it. So what you get is a cone on x. Now in the suspension, you identify the top part and the bottom part also. So you identify this to a cone, and then the bottom part is also a cone. So there are two pieces of cone in suspension. So in suspension, you identify this part to a point. So this entire circle here, this is identified to a point. So you get something like this. So this is called suspension of x. So cone of x, just consider this identifying the top part, the top circle to a point, and suspension both parts. So obviously if you think of this as S1, this green circle as S1, and if you take a suspension of it, you put a cone above it and a cone below it. So this is same as S2. So you fill air into it, and this will deform to a sphere. So this will become a sphere like this if you fill air into it. and your equator is your S1. So the equator is S1, this part is S1, and this entire thing is S2. So this S1, and then you added suspension to it, you got S2, and that is what precisely it is. Suspension of Sn is Sn plus 1. Now we talk about the wedge sum. For wedge sum, you have two spaces x and y, and then you choose a particular point x0 in x and y0 in y, and then you identify these 2 points, these 2 chosen points, you glue them together, and then you get a wedge sum. So the standard example is S1 wedge with S1. So let us draw this. So you have S1, and then you identify a point, then you have another S1, and you identify a point, then you glue these together. Once you glue them, you get something like this. So this you will write as S1 wedge with S1. Then you could also have S1 wedge with S2, wedge with S2. So again you will take a point in S2, you will take a point here in S2, and you take a point in S1, and you will glue all 3 of these points together. So let us see this. So this is S2 wedged with S2. So you have taken a point of S2 and then taken another point of S2 and identified together. Now you want to make this S1 wedge with S2, wedge with S2. So again you will take a point of S1 and identify with this point, because all 3 of them will have the same point which is identified with each other. So all these 3 points are glued together. So S1 is say something like this. So this is your S1 which is glued with S2 and S2. So you have formed a wedge sum. So similarly you can continue putting other S1, S2 or S3 on it. Now we talk about product of complexes. So you have X and Y, they are 2 complexes. They have these cells EI alpha and EJ beta. So here IJ just simply denote the ith cell, and where alpha and beta range over all cells. Now this definition requires slightly more care. We have to put more conditions on X and Y for the product to be a cell complex, but here we will just take a naive point of view and assume that this product exists. So this was a definition, but to make this more precise and clear, let us do an example. So say S1 times S1. Now you know S1 consists of 2 cells, E0, E1. So you have E0, E1 times E0, E1, and just like in Cartesian product, you write this down: E0, E0, E1, E0, E0, E1, E1, E1. Now you see that this E1, E0 is just nothing but an S1. E0, E1 is also S1. Now this E1, E1, this will be 1 plus 1 will make it a 2 cell. So if you have E1, E1, this will become a 2 cell. You just add these 2 up. 1 plus 1 is 2. And this E0, E0 will just become a point. So this point is nothing but an intersection of these 2 S1s. So you say you take this S1 and you make this big circle out of it. You take this S1, you make a small circle out of it. So this point right here, point of intersection, is this point. So you have this thing S1 wedge with S1 right here, which is these 2, and this wedging is this point, and then you have to attach a 2 cell, and this will give you a torus. So the way you attach a 2 cell is you take these 2 sides and then you attach it to this rust color, and you take the green sides and you attach it to the green side, and then you attach these 2 sides to this side, and what you get is a torus. So this is the torus we get, and we can still see our S1 wedge with S1 inside it. So S1 times S1, this will give you a torus, as we have just seen. So notice that, as I said here, you have all the cells ranging. So this is the range of the cells. So this is alpha and beta. So alpha and beta could be written here 1 and 2, and this, the superscript, denotes the dimension of the cell. So here beta is also 1 and 2. So beta is, this is 1 and 2, and this alpha here is 1 and 2, and this I is 0 and 1. Similarly, this j is 0 and 1. So we have done our example. Now we come to smash product. So what you do is you take x smashed with y as x times y over x wedge y. Now an example is sm smash Sn is Sm times Sn over Sm wedge with Sn. This will give you Sm plus n. Now to see it clearly, you first write your product. Now see, this Sm consists of E0 and Em, and this Sn consists of E0 and En. So once you form the product, you have a 0 cell. The 0 plus 0 will give you a 0 cell. This is Sm. You could have written as E0 comma Em, doesn't matter. This is Sn, E0, En. And then you have Em, En. You add m plus n, you get a m plus n cell. Then you wedge it. Em, E0, this is Sm, E0, En, this is Sn. Now obviously you have this cancellation, and you have a 0 cell and a m plus n cell. So you're left with E0, which corresponds to this. 0 plus 0 will give you a 0 cell, and Em plus n cell. Now these are not two separate points. So the idea is that these two separate points are identified with each other. So these are glued, because as we saw in a previous example, these two points were glued to each other by these two circles. This S1 and S1, when you take them together, their point of intersection is precisely this glued point. Similarly, these are not two different points, they are glued together. So they are glued via these 2 points. This E0 gets glued with this E0, and that's why these two become a single point. That's why you have E0 here. And then these two are taken together, they become Em plus n. And this is nothing but the structure of Sm plus n. Now we can see this specifically in a torus. In a torus, you have S1 times S1. This is your torus. Now you modulo out S1 wedge with S1. Now according to this formula, you should get S2. Now S1 wedge S1 is nothing but this circle, this orange circle and this green circle. This is S1 wedge S1. So let us do this. Let us first collapse this green circle. So you will collapse this green circle to a point, because we are going to collapse both of them to a point. So let us do step by step. So let us collapse this first, and then we will collapse this. That is, let us collapse the green circle first. So if you collapse the green circle, so we have collapsed the green circle to a point now, and this is what we get. The torus is kind of pinched on one side. You still have this hole is right here. This hole here is right here. But you also have this orange circle. So this is your orange circle. Now you collapse this orange circle to a point, that is, this entire hole will also vanish. So this hole will vanish to a single point, and what you get is a sphere. So you collapse this entire thing, this hole, to a point, because you're collapsing this thing, and what you get is a sphere. So that is it. So visually you can see how things are happening. So in this figure, this is a hole. So let us make it black again. So we have seen this